Hi roboticist, today we are gonna talk about 2D camera and in particular how to plug a 2D camera in our simulated environment and how to use that to sense the environment for our robotic application. So we're gonna place one camera for the peak position and another camera for the place position. So we have already talked about this topic and in particular regarding a depth camera, but since that a lot of industrial application uses 2D camera, I decided to make a video for that. So make sure to stay with me till the end of this video so that you will be able to simulate a camera in Gazebo. Get image from the simulated environment and you will be ready to process the image like OpenCV to deploy a robotic application like pick and place to detect where the object to pick is. So before starting, make sure to subscribe to the channel, hit the notification bell if you want to be updated on the topic of this channel, which is about learning robotics with ROS, in particular for industrial application. And if you want to be a robotics software engineer and you start from zero, check out the course for ROS for beginners in the description down below. This course will equip you with the essential knowledge and skills to dive into robotics operating system ROS from scratch and build a solid foundation for designing complex robotics application like the one that we are doing now. So that's all for this introduction and let's get started. Okay, so for this video I decided to show you the Rviz or ROS configuration or ROS visualization to check where the 2D camera is and then describe you how these camera are designed in the XACRO file and in the URDF file itself. So basically what I'm gonna do is to launch this Rviz launch file. So as robot description, which is a ROS parameter, we are gonna use this cobot 2D XACRO file, and this cobot 2D XACRO file basically is the one that always our pick and place robots that we have always worked with in our tutorials, with the difference that there are two cameras plugged in, and for that I have described the camera in this XACRO file. So before to dive into the camera plugin, let's run the Rviz launch file and see what is going on. Okay, here we go. This is our cobot robot. This is the base link where is put in the 00 frame reference, and here in red you are gonna have the two camera. So one is gonna be in the peak position, so it will be here, and the other one will be in the place position, just to check if the object will be in the place position. Okay, so first of all, let's check the XACRO file where we describe this object, the camera. So we are going to describe the geometry of this and the physical properties of this camera. So let's jump into it. So this is the XACRO file that describe the 2D cameras. So to do that, I have described as a link, which we have named it camera link, is described by the geometry tag, which is simply a box. And then we have placed with the ref thanks to we have placed in our environment thanks to this joint which is of type fixed, so the camera will not move from in the environment, and we use as a parent link the base link, which is this small cylinder here, and the position here will be in x direction 1, y direction, y direction 0, and z1. So let's check it, and here it is. And I have put an angle of pitch 90 degrees in radiant, so in such a way that the camera is pointing downwards. So you're gonna see here that you have two frames, one for the camera link and one for the camera link optical. We are gonna describe it in a while. So to understand the camera link optical, you just need to know that we have a different coordinate system between the ROS environments and the way that a camera process an image. And so you just need to deal with it. So we have a link that is gonna be camera link optical, which I repeat is we are gonna put a reference frame for this link which relates to the coordinate system that ROS process a general image. And we need to put a joint between the camera link described here and the camera link optical that describe the new coordinate system, and this transform is set up here. So basically we have to put a rho and yaw angle of minus 90 degrees. This is how the camera is described from the geometry point of view, and here is about the physics. And if I remember you that if you deal with the physics, you're gonna need to play with the Gazebo tag. So here we're gonna have as a reference camera link, which is here. So we are going to attribute to this link as a reference all the physics described here. So what are the physics described? So basically here we are gonna have a sensor which is gonna be of type camera. Then the name, I put it camera 1 because in your environment you're gonna have another camera, which will be our case. For example, here this file will be the same of this file, with the exception that we change the name of the camera. Here is the horizontal, let's say, the field of view, and which is basically the more it is represented in a radians. So the wider this value is, the you have a focal length which is more opened, and if you decrease this angle, is meaning that you are zooming into the image. So then here you're going to describe the size of the image and the format R8, G8, B8, which is 8-bit for the red channel, 8-bit for the channel green, and 8-bit for the channel blue. And I remember you that an image is processed in 8-bit in 3 channel RGB. Red, green, and blue, and the combination of that from 0 to 255 makes whatever color you wanna have in your environment. And this is represented as the range where the camera is able to sense the environment. So it's able to see at 50 millimeters from the origin of the camera and till 8 meters. And basically here we are gonna use so this here is how to check how to deal with the noise of the environment, which is gonna be more interesting when you're gonna put a real camera. And then then we need to put a plugin which relies on these libraries here. And here a very important thing, so we are gonna use as image topic name image raw. So basically the camera is going to publish the image which will be of type sensor underscore messages slash image in the topic image raw. And the camera info will store all this information here is regarding the physics of the camera itself. Okay, so that's all for the description of this camera. As already mentioned, the camera 2 is gonna be let's say identical to the one that we have described, with the exception that is gonna be placed in another way, in another place, which is gonna be here. Okay, and now we have everything for testing. So I have prepared this launch file, which basically is the same launch file that we have dealt with in the last video, with the exception that we have changed the XACRO file to link to the ROS parameter ROS description. And I remember you that this launch file is able to link the Rviz with the MoveIt plugin and interface with Gazebo, which in our case will be the simulation of our real environments. So let's close this. And let's launch this launch file. Okay, here we go. We have our camera here in our environment. This is camera 1 and this is camera 2, and this is represented here. So if we want to check what the camera is seeing at the moment, we just need to add components in our Rviz, and we're gonna choose a camera. and we need we need to tell which topic is publishing to, and we have seen from our description that it will be of type, it will be image raw camera. So let's we should find here. Let's go to the image topic and we should find correct cobot camera, which is our namespace. This is the name of this camera, and the image raw. So camera 1 is this one, so we are expecting to see the top of this object, and here we go. And let's see what the camera 2 is seeing at the moment. So we need to do the same exercise, and but this time we will need to select the as an image topic the cobot camera 2 image raw, and we're expected to see gray. Okay, so what I think that will be interesting to do now is to run our pick and place application, the simple one, and see how the camera sense the environment. So basically, let's put this here, the camera 2, that we are gonna see what this camera is seeing, and let's put this one here. So let's open another terminal and let's run the Inverse Kinematic for a pick and place simple application. I'm gonna put the link in the description down below, and basically it's the last video, but I'm gonna provide the link in the top right corner of this video. Okay, the robot is moving. And so in a while we are gonna see the gripper here that is taking the object from the top. And here you can see that you start to see from the camera the gripper that is approaching from the top the object. So you can see the gripper left, gripper right, then the gripper connector, the link 5. Okay, so we are approaching. Okay, now we are in, we have reached the pre-grasp position, and then we are going to approach in the object. We are going to close the grippers. And then we are going to put this object in the place position, and in a while we are gonna see it here. Okay, now you can see that the camera 2 is seeing what is going on in the place position. And then we can see that we have the object that is placing where we have asked the object to be. And you can see now that it has released and the application is finished. So that's all for today. I hope that you enjoyed this video. In the next video, don't miss the next one, because we are gonna use again OpenCV to detect where the object is from the camera 1, and we are going to rely on the detection of the object of the camera 2 to check if the object has been placed in the correct position. And that application will be very useful if you are going to use a camera for similar application in your robotic application in industrial environments. Again, thanks for your attention. If you like this video, make sure to subscribe and hit the notification bell, and I'm going to prepare a more detailed video in another ROS course for intermediate level. And put a comment down below telling me what do you think about this type of content, and keep learning robotics with ROS.